Welcome to The Explainer. Today, we're digging into the engineering hidden inside high-voltage underground cables.
So how do you do that? It's a huge challenge and one that really tested early engineers.
Okay, so our story starts with a classic problem, moving massive amounts of power through packed cities.
See, going underground is super expensive compared to overhead lines, so these cables have to be rock solid.
The problem was, in the early days, they just weren't. High-voltage paper-insulated cables kept failing, mysteriously. And at high voltages, these failures completely baffled engineers. The enemy, it turned out, was invisible. So what was it? Something called partial discharge. Think of it like tiny lightning storms inside the cable.
As the cable heated and cooled, tiny gaps formed. These voids became hotspots, slowly killing the insulation.
So the big question became pretty simple. How on earth do you get rid of those voids? Well, in the 1920s, an engineer named Emanuel Yoli had a brilliant idea: the fluid-filled cable. Instead of letting voids form, he used pressurized fluid to fill every single gap. Problem solved. And this idea led to some really cool designs, like the Moeller-Hoge submarine power cable. Now, pressurized paper was a total game changer, but engineers were already looking for something even better. Enter modern plastics. Something called XLPE gave you amazing insulation without all the complicated pressure stuff. And when you compare them, you can see why. XLPE could run hotter and wasted way less energy. But, a cable's only as strong as its weakest link. That's almost always the connection points. These joints aren't made in a factory. They're built by hand, on site, which needs insane skill. And these connections have to handle huge electrical stress and even bigger physical forces. No room for error. So all this incredible innovation, it's all about one thing: pushing more and more power through. And the demand for power just kept exploding. Look at the UK. Voltages nearly tripled in just 30 years. To handle all that juice, the copper or aluminum core inside these cables had to get seriously huge. This all comes down to a cable's ampacity. And everything affects it, from the insulation to the dirt. So as our world demands even more power, you have to wonder, what's next for these super cables?